Hey, good morning, everyone. And I guess maybe good afternoon to those of us on the East Coast. We've got a couple minutes, so we'll just wait for a few more people to trickle in, and then we'll get started right around 10 o'clock, 10 o'clock Mountain Time. All right, we'll get started now. Hello, everyone. Thanks again for joining today. My name is Adam Travato, and I'm with Sustainable Projects Group. And today I'll be presenting alongside Nick from Ecopilot. And we will be presenting on energy auditing and optimizing HVAC performance through the use of artificial intelligence. So before we get started, I'll introduce myself. My name is Adam. I'm a certified energy manager and energy technologist who has spent a large part of the last decade in the energy efficiency industry, doing energy audits, and now working a lot to work with energy audits to develop energy efficiency projects and make sure those projects get implemented and then measured and verified correctly. So I'll let Nick introduce himself when he gets into his presentation, but as mentioned, he's with Ecopilot and he will be presenting the latter half of this presentation. So just before we get into the meat of the presentation, so an agenda for the presentation shouldn't take the full hour. So at any time, please feel free to put in any questions and we'll do a Q&A period at the end and get everything answered for you. So, but yeah, so really we'll start off with an introduction to SPG, introduce what is an energy audit, the benefits of an energy audit and why building owners tend to get them, and what you can expect from a final deliverable. And then I'll kick it over to Nick, who will take us into the interesting part of the presentation. So who is SPG? Most of you probably know this, but SPG is a design, build, energy efficiency, and sustainability contractor that works to provide turnkey energy efficiency and sustainability projects. So what that typically means is we start with an energy audit or some sort of energy efficiency analysis, and then we'll work to provide that energy engineering and design work, and then rebate applications, funding applications, and then we will work with our contractors to actually implement the project. We work across the country with a focus in Western Canada, having offices in Vancouver, the Okanagan, Calgary, Edmonton, and a satellite office in Toronto. And we do have many active projects throughout Ontario, Manitoba, Saskatchewan, and the Yukon right now. So getting into it, what is an energy audit? So an energy audit is an assessment of a building that displays the current energy use of the facility, along with the associated costs and needs of the building, while communicating methods to reduce the consumption without negatively impacting the building. So more simply put, an energy audit is a report that tells you what's going on in your building and provides you pathways to improving your building by reducing the building's utility expense, carbon footprint, and improve its overall functionality. And you know, one key thing, and that's sort of in vogue today and will likely be pretty relevant for the next, 10 to 15, 20 years, is it does provide you sort of that first step to the pathway to net zero by identifying not only the low-hanging fruit, but some of the larger capital projects that can bring your facility to that net zero. So some of those, larger building envelope projects, renewable energy projects, and HVAC projects. So beyond that, an audit will generally provide the building owner with upwards of 10 potential projects. That does depend on the building, but that will help reduce the utility expenses, greenhouse gas emissions, and so forth. And all these measures are accompanied by several environmental and financial metrics, such as simple payback, net present value, return on investment, greenhouse gas savings, and capital cost, which allow for more effective capital planning and decision making. And in terms of what we actually look at in the building, we're looking at, everything from top to bottom. So the HVAC, building envelope, electrical, lighting, renewable energy potential, controls. We're going to do our best in the site visit. Obviously, we're there for a limited amount of time under the scope of most audits, but to take a look at the occupancy habits, see how people are actually operating the building, whether they're turning lights off, keeping their computers on after work, and so on and so forth. And then identify distinct projects that can help rectify some of the inefficiencies within the building, like an LED lighting retrofit, variable frequency drives, condensing boilers, and so on and so forth. Furthermore, the energy audit will provide an opportunity to address and investigate known problem areas in the building, such as overlit areas, leaking building envelope, air quality issues, and so on. So often we find that, wasted energy in the areas in a building that might be perceived as inefficient are also areas that are causing occupancy complaints. So often when a building is functioning to its maximum, it's also operating quite efficiently. And then in terms of what type of audits there are, because there's a bunch of different lingo that goes on there, there's a level 1, 2, and 3 audit, which are the kind of the standard levels of audits that are out there in the industry. A level 1 is a walkthrough audit of the facility, which is, at a high level, identifies some projects, but isn't quite the class of estimate that allows one to, plan projects very accurately. Level 2 is kind of the next step in sort of the industry standard. It's a detailed energy audit that goes a step further in the level of analysis, accuracy of the analysis, as well as, kind of the detail in the report, and so on and so forth. And that's typically what this report will focus on, or this presentation will focus on. And then a level 3 is an investment grade audit that takes elements of the level 2 audit even a step further by requiring full building energy modeling and individual data logging. And this is typically done for investment grade audits or large grade investments that are involving, an energy service contractor or, a third party financier that wants to really be very certain that the measures that are going to be implemented will result in the savings that are communicated. And I guess just to get a feel for how much experience everyone has with energy audits, got a little poll question here. So have you completed an energy audit on your facility or another facility? So some people are going to be building managers, some people are going to probably have actually completed energy audits themselves from a consulting lens. So just want to get a feel for it, and can probably kind of drive the level of detail that I go into based on that. Give it another couple seconds. Have a sip of water. Okay, so 63% of you have completed an energy audit, whereas 38% have not. So, or sorry, 63%. There's a hair on my computer. So yeah, it seems like we've got a pretty good amount of us that have experience with energy audits. And then just because I was chatting about this earlier in the presentation, but we talked a lot about return on investment, net present value, simple payback. And we find that most organizations have different thresholds in all of these. So just out of curiosity, what would your organization, if you're in this position, consider a reasonable return on investment for an energy, it's cutting out energy conservation measure? So if you were evaluating a project, what kind of payback or return on investment is what your employer or yourself looking for? Very cool. Okay, another couple seconds here. Awesome. So yeah, this is pretty interesting. So 23% of you said 2 to 3 years, 64% said 4 to 5 years, and then 14% said 6 to 8 years. So yeah, and that's what we find a lot of the time when we're evaluating these energy audits, is each client is different and has different priorities, different budgets, and different thresholds on these things. So it is interesting to always see that firsthand. Okay, so moving on. Why an energy audit? So I won't go into too much detail here. It seems like most people are familiar with it and are here, but there are a lot of different reasons why individuals or companies perform energy audits. It can start from environmental, which is typically associated with greenhouse gas emissions and trying to lower the carbon footprint of the facility. There's technological reasons, so looking to actually improve the facility itself and make sure that there's new technologies and high functioning technologies involved. And then there's financial reasons, which is almost always involved in the decision making, which is those paybacks, the return on investment, the net present value of a given measure, and the capital cost and budget that we're working with. There's social reasons to do so. There's green building certifications, things like that, green imaging. There's a lot going on now with political pushes towards greening buildings and whatnot. So we're seeing a lot of active funds that are available. So a lot of building owners are actively pursuing energy efficiency funding, which requires energy audits. So there's a lot of different reasons to perform an energy audit. And a lot of the time, the decision making fits into more than one of these boxes. As far as the benefits of an energy audit, probably preaching a little bit to the choir, so I won't go into as much detail as I normally do. But as you can see from the bullets, there's a lot of benefits of an energy audit. There's benchmarking and understanding your facility. That allows you to set a baseline and just have good data to work with, which is important. But it is as well allows you to check in, see if you have a new contract that's warranted, if you're on a good utility bill. As we see right now, there's a ton of different conversations around the price of electricity, natural gas, and doing an energy audit gives you a good opportunity to look at what you're paying, what your rate is, and what's out there. Energy conservation measure and project identification. So that's pretty straightforward. That's when we actually look at the projects that are available. And then This now allows you to make an apples to apples comparison between two very dissimilar projects. So if you've been considering a boiler project and a lighting project and a windows project, and you only have budget for one, you can now evaluate those very clearly based off several metrics, and then identify which project best suits your facility. And then, once the projects are identified, we do work within the parameters of the building and the building owner, such as budget, equipment replacement intervals, occupancy, tenant changeover, and so on, to provide a pathway to and clear next steps to lowering greenhouse gas emissions, lowering utility and operating costs, accessing rebates and subsidies, which is really important because some of them have really finite timelines, and then improving the building functionality. And then one thing that we find pretty critical is it actually does allow the owner and the operators of a building to pair that process of capital planning, asset management, and sustainability into a single plan and process that maximizes the dollars invested into the facility. Okay, so the process of an energy audit, not overly complicated, really. We typically go into a building and meet with the building rep. We discuss the scope of the audit, schedule, goals of the facility, setting the timeline and expectation, and so on. Once scheduled, we'll do a site visit, which will include a couple auditors, usually one or two, depending on the size of the facility, sometimes three if it's a larger facility, arriving on site, interviewing site personnel, going through the entire building, measuring and recording equipment such as windows, boilers, doors, furnaces, lighting, HVAC equipment, controls, and so on. Basically, the auditor goes through and records everything that relates to energy consumption in the building. And then we take pictures of everything, record nameplates, and complete thermal imaging tests of the building, and really get a good feel for what is in the building. So when we go back to the office, we know exactly what's what and how it's performing. And then either on-site or off-site, we're going to collect the utility data, building drawings, any past consulting reports, quotes, capital plans, equipment logs, any data that you have, and we're going to try and incorporate that into the report to get a better image of your building. And then following the site visit, we go into a largely engineering exercise in which we go into desktop analysis and energy modeling. All data is uploaded into an energy modeling, which builds the building in energy software. And then we produce an anticipated energy consumption of the facility. We calibrate that to the utility bills and weather data. And then we normalize it to create an accurate energy model. Once the energy model is created, we have a very detailed and iterative tool that displays the respective energy use throughout the facility and pathways to reduce that energy use. And then to determine the savings of each measure, the auditor inputs changes into the energy model, and that produces a new building with that upgrade within it. And then so once we produce the energy model, we do ECM and project identification and report delivery, which essentially we take all the projects we've identified and all our energy modeling and utility data, and we put it into a final report. We communicate that back to the client, and then we like to work with them on the next steps and help try and implement these projects. And just to wrap up here, a couple slides on the final deliverable and what you can expect from an audit. So here you can see pretty straightforward. You've got facility description, utility analysis, energy end use breakdown, the ECMs, next steps, and summary, and then just some snaps of these. So with the utility analysis and benchmarking, right now, here's some electrical benchmarking. This displays 4 years worth of utility bills, as well as an average and base load. And here we can point out any anomalies, which prompts the auditor to discover what might have created that anomaly. So sometimes there's a construction project, a system failure, empty tenant space or something, and it allows us to see why a certain year was lower or higher, and make some assumptions on that. And then here's some of the data around the costs of that building and some of the metrics that are used to evaluate those. And here's the utility cost breakdown. So this shows that this was a very electrical dominant facility. 72% of their costs were wrapped up in electricity, whereas 20% were on natural gas and 8% on water. And here's just another way of communicating that in terms of dollars per square or per meter squared. And then there's the energy end use breakdown. So this takes a look at what within each of those utilities is actually creating or is using the energy. So ventilation is a major cause for concern in this building, as you can see, as the HVAC is taking up, more than 50% of the electricity use, and then, almost 100% between the makeup air units and the boilers of the natural gas consumption. And then here, I've got two slides, I'll flip back and forth here, but here would be the energy conservation measures. So this is typically what most of the clients are most excited about, is finding out what projects they can take a look at within their building and what they cost and what the impact's going to be. So here you can see project cost, the utility savings with the three major utilities that they're paying, the annual cost savings from a utility and then maintenance savings standpoint, and then the same measures here with simple payback, the measure life, the net present value, and the GHG reduction and from an annual and lifetime standpoint. So, you can see in this building that there were a lot of opportunities that provided a positive net present value, and then a lot of opportunities that didn't. So I find that with energy audits, a lot of the time, some people just like to recommend the projects that do make sense. I'm a proponent of it also makes sense to communicate the projects that might not make sense from a financial standpoint, so that whoever's working with the report can understand that you may need to do a window upgrade, but don't be convinced that the window upgrade is going to pay for itself, because everyone knows that a triple pane window is going to save you energy, but how much is that going to save you? Well, at the end of the day, it's not going to be enough to justify it on a standalone basis. Whereas if you look at this BMS upgrade, that does have enough financial backing to justify it on the lifetime of the project. It will save you $17,000. So that's pretty much how we tend to look at the ECMs and why we still do believe that it's worth communicating even these projects here at the bottom. So with that in mind, I'm going to hand it over to Nick, as I have gone through more than enough of energy audits, and he will take us through his PowerPoint here. And while we do that, I'm just going to let Nick share his screen. So go ahead and steal that from me, Nick. Perfect. And while I'm doing that, I figured we could do another polling question, which is, do most of your buildings have a building automation system or building management system?
This is one I'm always interested to find out.
Yeah, and we've got some pretty varied results. I'll give it 1 second here, and then I will share the results. So 32% are a yes, 44 are some, only 8% are no, which is pretty sweet, and then 16% are unsure, And then just quickly before you dive in, Nick, I've got another one. So just as a precursor, do you feel like your BAS is doing everything it can to reduce energy consumption and maintenance costs?
Another interesting one before I get started. It's always nice to have a little bit of insight.
Yeah. And it's looking like not many people are totally happy with what their system is doing, as we have only got 8% of you that are saying yes.
Well, it sounds like everybody's in the right place right now.
I think so. So I'll hand it over to you, Nick, to kind of take over here, and I might jump in with a few more polls at a few points. But other than that, have at it. Yeah,
by all means, stop me whenever you want, and if people have questions in the chat, stop me if you want me to answer it if I'm on that topic. So a little bit of an introduction. My name's Nick. I'm with Ecopilot. I'm based out of Calgary. I've worked in oil and gas as a control room operator. I've worked in clean tech and energy efficiency projects. And now, yeah, here I am with Ecopilot. I just recently got my certified energy manager designation, like Adam. And yeah, so I'll kick it off now. It sounds like we've got lots of people interested to see how they can improve their BASs and their HVAC. As Adam pointed out during his presentation, it's a huge energy load for a building. I remember in one of those pie charts you had there, it was huge consumption for boilers, right? And ventilation was a big one. So that's what Ecopilot's here to do, is reduce that energy consumption on those kind of systems. So what Ecopilot does is we're an AI add-on to an existing BAS or BMS. And we use this AI to optimize efficiency. And I'll go through how that works as we go. If your building doesn't have a BMS or BAS, which it sounded like most do, that's another thing we're happy to install as well. It's just that's not our main focus. Right. So this is how we're going to tackle this. We're going to go a little bit of an overview, how it works, our process, our guarantee, and a virtual demonstration. Typically I go live, but sometimes you can have hiccups. So I've just taken screenshots from a building the other day. So that'll be a little different than normal. And then I'm happy to do some Q&A after that. So a typical building automation system is reactive. It looks at the outside air temperature and it changes as the outside air temperature fluctuates. So it's seeing the temperature change and then it makes it change. What Ecopilot's doing is it actually works proactively. It learns the building, its thermal capabilities, and looking at weather forecasts, and it'll plan ahead. So as I kind of alluded to, there's three main things that make Ecopilot different than other systems that kind of do the same thing. 60% of our energy savings comes from thermal storage. So what does that mean? We're not installing a big, thermal tank of anything. What this is actually already in your building. It's the building materials itself. An ideal building for Ecopilot is thermally heavy. So it'll be made of concrete, brick, or stone. And what these materials do is they absorb heat and release it over time slower than, say, materials like glass, metal, wood, things like this. So what we do is take advantage of those buildings with a concrete base, brick, etc. And those buildings are actually able to maintain their temperature for longer. Typical BAS isn't going to quite understand how to navigate that. It's just trying to hit its set point for an internal temperature in the building. So yeah, that's what the AI does there. We also add another layer of coordination for technical systems in your HVAC system. So that's the heating, the cooling, so like chillers, boilers, RTUs, AHUs, VAVs, things like that. We're making sure that they're actually working as a cohesive unit, which, they may already be with your BAS, but we're going to have that extra layer of understanding the thermal storage and the weather forecast. So there's, for the weather forecast, we look 5 days in advance. And we look at, is there going to be precipitation, wind speed, solar radiation. We map out how much solar radiation you're going to have on a certain side of the building, things like that. So you're just doing what a BAS does, but you're just giving that extra layer of intelligence and planning ahead. And to illustrate this, this is from a building we did in Toronto. As you can see, the temperature on the left-hand side, the yellow line there, it's dropping down as it gets colder outside. So what does a BAS do? It sees the temperature go down, it starts going up. It's compensating for that colder weather, which is, that's normal. What Ecopilot's doing is it's calculated, all right, we know we have X amount of tons of concrete in this building. We know we've got people coming in today. We know there's machinery in the building, such as computers, lights, things like that. There's a lot of free energy that we can capture. We don't really need to ramp up the heating system as much as, what the BAS is typically accustomed to doing. So as you can see, there's a slight hump in the red line just below the green. And it's saying, okay, that's it. And the building was able to maintain a temperature of 22.7 degrees. Whatever the preferred temperature ranges, Ecopilot will work within that. Typically, a building will be like 21 to 24, preferably. Typically, that's where we aim to be. But whatever the preference of the building management is, we'll abide by that. So we're not sacrificing occupant comfort whatsoever. And during this period, we had 44% natural gas savings. And I'll go into more about that in a little bit here. So I've already alluded to a couple of these things, but what makes a good building? We need a thermally heavy building. We're using it as a battery or a bank almost. A building automation system, it's just easier if it's already there, but if it's not, we'll make sure we get the right people in to install one. There's different levels of sophistication. We'll make sure that works out to whatever the property manager prefers. And centralized HVAC. So one thing that this Ecopilot technology doesn't do is a room-to-room basis, and I'll get into that during the demo period. But what we're trying to do is just the centralized systems that we can get the biggest savings in, and that helps us have the better coordination of the different systems. We're not going to be playing with everybody's individual thermostats. That's all going to be left in the tenant's control still. We're not taking that over. So why do customers love Ecopilot? We give real-time HVAC energy savings. And I'll explain a little bit more about that. There's some other players out in the industry that will go into a building, they'll analyze the patterns and stuff like that, and try to start making smarter decisions. Ecopilot's been doing this for well over just about 15 years now. During our assessment of a building, we're able to pretty much nail it right out of the gate of how we're going to better control the building. I'll go into how we can make some small adjustments as we go later. But yeah, we start saving on day one. There's no learning curve after the assessment's done. So that's real-time savings. We also guarantee our savings. We're very confident in our ability to reduce. So during that assessment period, we'll map out exactly how much we'll guarantee you. And if we don't hit that guarantee, we'll cut you a check for the difference of what you didn't save for electricity or natural gas. And no fee install, so no surprise costs. What we typically do, there's two options. We'll do a major, like a capital project, or we'll do an energy savings agreement where we say, whatever you save on top of the baseline that we've established ahead of time, we'll take that and then we'll pay off the project in that way. And so as I mentioned, we've got comfortable tenants, they're happier, less cold calls. That's another major benefit of Ecopilot. We've got 1,200 installs worldwide, so that's where our confidence comes from to do an assessment and make sure that we're confident we're going to make those savings. We average 25% annually in energy savings, so that's a mixture of heating, so natural gas, chillers for cooling, and also some ventilation. Typically, that's the smaller of the savings compared to the rest of them, but typically it's 25% savings, as high as 40 sometimes, depending. It was interesting during the poll. I was happy to see that some people are quite happy with the 4 to 5, 6, 7 year ROI. Well, we've got a 3-year, so that's our big claim to fame. That's an average, you know. Sometimes there's a building with 4 or 5, depending, but other times, I'm going to go into some examples, but sometimes we've had clients pay off their project in 1.5 years or so with their energy savings. It just depends after we do our analysis. So energy savings is our main objective. However, there's a lot of nice periphery and bonus benefits to going with Ecopilot. We offer fault detection. We make maintenance plans and recommendations for additional energy savings. Say you're to sign up with Ecopilot, after the first month, you would end up with a report that we'd put together. We'd figure out how to optimize a little bit further, make some small tweaks, often with this extra layer of monitoring on your building. We find some other opportunities. It's kind of a light energy audit in a way, nothing as sophisticated as what SPG does or anything. But this kind of adds another lens to the building, and we're able to come up with some more additional recommendations. Maybe it's adding a VFD to a pump, or maybe there's a need for a 3-way valve, things like that. So that's another benefit. So we have that monthly report, then we do quarterly updates with the client, and then we do a much more deep dive annual one at the end of the year. And then after that, everything's typically tickety-boo, and we'll just do annuals from there on in. So after you install with the Ecopilot, it's not like we just disappear. We're there alongside. We like to think of ourselves as an extension of your maintenance team as well. So if you're interested in Ecopilot, we do a complimentary building assessment and proposal. There's no fee, no obligation. Part of that proposal will include a energy savings guarantee. So we'll tell you exactly how much we're going to guarantee that you're going to save, and then we'll also tell you how much we actually expect you to save as well. And at the bottom of the screen here, we've got Class A buildings. This is a new feature for Ecopilot. For anybody that's concerned about energy demand charges, they can get pretty hefty. We've partnered with an organization called Empowered, and they are also an AI organization. And what they do is they predict different high energy demand periods by monitoring the electrical grid. So what Ecopilot will do is get a message from Empowered, realize, okay, we're going to have a high demand event coming up. We want to avoid those charges. So Ecopilot will prepare the building ahead of time, heat it up, cool it down, whatever it needs, and will then curtail and maybe even shut down boilers or chillers if needed, and you can avoid those extremely high energy demand costs. Do you want to do a poll maybe? This might be a good time.
Yeah, I will throw one up here. So speaking of, funding projects and whatnot, how would you ideally fund a project, or how do you typically in your organization, are you able to fund projects? Do you need to go through government incentives? Are there energy savings agreements or ESCOs, or just capital investment? Do you normally just get that on the capital budget?
I'm interested to see this one too, because it really depends on who you talk to, I find.
Yeah, agreed. And it looks like there's a pretty nice split here, and this is one where you can answer more than one. So okay. So yeah, on this one, 61%, and this could be based on how the questions worded, but ideally, yeah, it would be nice if we could fund projects through government incentives. So definitely glad to see that people are recognizing that it is nice to get that support. And then, yeah, capital investment, 44% of projects are just getting it on the budget. I think it probably depends on the scale of how innovative or how energy efficient a project might be. Some projects are just sort of, exactly the same as maintenance projects, so they can be sort of synonymous with that. And then there's energy savings agreements and ESCOs, so 39%. And then maybe I'll throw one more up, but what would be the largest roadblock to implementing energy efficiency projects? So management support, upper decision makers supporting it, the technology options, return on investment, capital costs, and then just your time. Yeah, and this is what I would say is pretty typical is, most of you are answering around capital costs, which is why, government incentives and things like that can be so, that's why those are both the top answers, because if capital costs are stopping you from investing in something and there are government incentives that can help lessen that burden, then, it makes a lot of sense. So, okay, I'll hand it back to you, Nick, to continue.
Okay, sounds good. Just listed some of our customers. I guess I didn't mention the types of buildings that we typically are most effective in. We're definitely installing in a lot of multi-unit residential buildings, a lot of shared office space, so like office towers, a number of schools, hotels. What we don't do is industrial. We're not going to go into a pulp and paper mill and save them money on their HVAC or anything like that. This is occupied spaces is where we specialize. Speaking of which, here's some examples of some buildings. These are out in Halifax. That's where the company got its start in North America. So that's where a lot of our examples come from. But before that, we originated in Sweden, so another northern climate similar to ours. As you can see here, lots of natural gas savings. These buildings didn't have cooling, so that's why it was just natural gas. We had an exciting project out at the Marriott and the Halifax waterfront, saved $100,000 in the first year alone on their utility costs. They had an energy savings agreement with us, and it was going so good after the first year, they just paid off the rest. They found it in their budget, so they were quite happy. Another one of the original buildings we did too, we had 25% savings here in Cogswell Tower. Again, this one was also in Halifax, but as you can see, it's under 2 years for an ROI. They were so happy that they actually expanded to the rest of the campus. You can't see it in this picture, but there's actually a shopping mall underneath and some more office space. So they, after they saw the savings, they kept on going. So this is our non-live demo. This is a building in Toronto, Minto Properties. You might be asking yourself if, I've got an energy efficient building, is this a good idea for me? But the thing is actually, it actually brings our costs down typically. You probably have a sophisticated BAS. You probably have a lot of temperature sensors in a lot of older buildings. Sometimes there's only one spot where they're reading the indoor temperature in the whole building. And that's what they're setting their boilers to. So don't be discouraged or don't think it's a waste of your time if you have an energy efficient building. If anything, it'll bring our costs down and it'll bring your costs down. So you can bring that further. So this is a good example of that. So this is the dashboard that you would see on your Ecopilot access. This building has heating and cooling. And as you can see, these fuel gauges here, we've got what we call the reference, which I prefer to call the baseline, but that's what the language they use. So the before Ecopilot was here, this is the amount of energy that they expect to save. And you're going to see watts per square meter right under it. So that's how much energy that we put into the building to maintain a comfortable temperature for the tenants and occupants. So the natural gas in this example, this is a summer example, so that's why there's really no difference between the two. But if you look over to the right, because this was just a few days ago, the cooling is we're saving 2.5 watts just about compared to what the building was beforehand for every square meter. And then we're saving an additional 0.6 watts meter squared on top of what we expected to save. So we're actually surpassing our expectations there. So that's what those gauges mean. So to see how the building is performing. If you look in the bottom left here, we've got room temperatures. This kind of gives you an idea. We break the building into different zones, and so that's what you see: lower east, lower west, and the corridors, etc. So as you can see, most of this is green. We do have some reds, but red doesn't mean you're not in the comfortable temperature range. It just means you're on the higher end of it. So you have an idea of how it's transitioning. So you know those ones on the right, yeah, they're probably as high as you want it to be, but also you've got a lot of greens and blues. So you have a pretty good understanding that the building's doing well. And then on the bottom right, the weather forecast, we've done a lot of installs where, you know, the building operators used to his building performing, building performing a certain way, and maybe they're just a little perplexed as to why, you know, it's cold outside and it's the boiler's not ramping up and the ventilation's not blowing harder, and just maybe confused about that. We've got the weather forecast there to see, like, the temperature maybe is going to be changing tomorrow. We're planning ahead. We know the building can withstand this temporary temperature fluctuation. So that's why we include that on the dashboard. As you can see here, we've got temperature sensors in each of these zones. If you remember from that summary of the Minto building, each unit actually has its own temperature setting, or sensor. And that's definitely a luxury. We don't always expect to see that, but it's nice to have a better understanding of the building. It's a little bit warmer on the right-hand side. That's actually the south side of the building. That's where you're going to get the most solar radiation. So that's quite typical, but at the same time, you see a lot of blues. You have a nice mix. We're changing the central supply temperature, right? We're not controlling room to room. It's of course better to know how each zone is reacting. Yeah, we're just the mean supply temperatures. So here's an example of how we can monitor how well we're controlling the building. So again, we are focused on watts per square meter to keep everybody comfortable. As you see the yellow line there, that was the reference. So that's the baseline. That's what how the building would react at different temperatures, how much energy you would expect to require to keep the tenants comfortable before Ecopilot. Green is what we guaranteed as an average. Obviously, sometimes you're going to have some anomalies. So green is what we said we'd do. And then on top of that, as you can see, these little dots, these are a day of the year, essentially. The blue dots and the red dots are a day of the year. So as you can see, the majority of the dots are below the lines. That means we're saving and surpassing what we expected and promised. And then the red ones, just for reference too, are actually the last 30 days. And that's because it's been warmer out, that we just transitioned into summer. That's why all the red ones are on the right and all the blue ones are on the left. The red ones just indicate the most recent. So you have an understanding of where we're at recently. So that's gas. Here is the same, but it's reversed because it's cooling. So as you can see, as the temperature goes up, there's more energy required to maintain it at a comfort range. Oh, and I should point out too, on the bottom right-hand side, you can see just in this little snapshot how much we've saved. So say you're interested in learning more about Ecopilot and how we can help support your energy goals. There's two different ways we can do it. If you have a large portfolio and you're not quite sure where to get started, we have a pre-qualifier checklist. It has just like, I think 4 or 5 simple questions that just gives us a general idea of what the building makeup is, and it can help us prioritize which one we think we could save the most on. So we're wondering about different building materials. Is there temperature sensors already in place? Do you have a BMS? And what type of systems do you have in your building? After that point, or we can even skip that if you just have a building in mind, we'll go to the building checklist. This checklist gives us everything we need to assess a building. There's more detailed questions like, square footage, how many people are in the building on average, things like that. And then on top of that, we prefer to have read-only access to the BMS, so that lets us click around and have a good understanding of how your systems are set up. We also like to see some HVAC drawings if possible, and they're not always available. And then utility consumption history. So that's how we create our baselines. And then as part of our projects, we'll install an energy meter to ensure that our M&V is accurate. We're saving what we said we would save. And that is it for me. Is there a chance to do a little bit of Q&A maybe?
Yeah, I'll take us through the questions, I think. So I'll start with some administrative ones. So yeah, do we have the slides available to download presentation? So yeah, we've recorded the presentation, so we can make that available to anyone. Feel free to reach out to me if you would like that. Kevin mentioned that their payback criteria really depends on the scope and magnitude of the ECM. So that's in response to one of the poll questions, which is a good comment, and definitely is received and understood. Yeah, it was more just a poll just to kind of get the conversation going about it. But yeah, we definitely understand that there's some variance there. And then is brick and concrete construction better than wooden frame construction? 90% of buildings are wooden frame. Oh, why is that so? Okay, so yeah, that would be not necessarily purely an energy efficient decision, I wouldn't think. So there's pros and cons to both of those. Wood frame is obviously, or not obviously, wood frame is typically lower cost up front. And is less embodied energy, less durable, and will last less time than concrete. I would think that the reason 90% of buildings are wooden would be its adaptability and its upfront cost. So,
I was just going to add too that a lot of wood buildings are smaller, maybe multi-unit apartment buildings, only a couple floors high, homes, things like that. Typically where Ecopilot's going in is more commercial spaces, office towers, rec centers, community centers, things like that. And those are typically, concrete construction more so than wood.
Yeah. And I would tend to agree that, concrete, if you're evaluating it from a pure energy efficiency standpoint, would be a more efficient build. But there's so many variables to look at within that it's hard to say. Yeah, so I agree with what you're saying, Nick. And then, so Mark, my good friend Mark from eDecisions has said, I'm unclear, so this is targeted, I think, towards a comment you had, Nick. So I'm unclear as to why forecasting a future high grid demand will increase my demand charges. I can see that a forecasted high grid demand will increase the hourly grid rates, but my demand charges wouldn't be affected. Do you have a comment to that, Nick?
So I will say I'm not an expert on this. This is a new aspect of Ecopilot that we just started advertising. I haven't actually done an install on it yet, but from what I understand, and there's probably some other better qualified experts in the chat, essentially is if your demand goes up, it's going to put a lot of stress on the grid, and that's why they charge you more, right? So if you have a huge A-class building that I don't know, maybe it's a super hot day, there's a lot of air conditioning running, there's lots of people in the building, computers, things like that. Your building demand is just going to go through the roof, while the energy companies will charge you extra for putting more stress on the grid and and what they need to do is ensure that they are able to supply a peak period. So there will be a demand charge associated with that. So what we're doing is trying to avoid that by monitoring what the demand of the building is. To be clear, this isn't consumption, this is demand. So basically, instead of the amount of energy, it's the intensity. So yeah, that's what we're trying to avoid. Do you have anything to add to that, Adam? Like I said, I'm not an expert on that, to be honest.
No, I wouldn't have anything to add to that. And but yeah, I think that, yeah, I definitely hear what you're saying. And then I think Mark's standpoint is probably just a different mechanism of getting charged that. So that extra. So maybe it could be a semantics thing. And then another question would be, how would Ecopilot platform respond to changes in electricity prices, such as time of use pricing in Toronto?
I think that's something we would like to look into. Not all markets do time of use. That seems to be an evolving thing. I know in Nova Scotia they're starting, but we don't have that really in Alberta. But that is something we'll be looking at implementing. But yeah, that's not part of our programming at this time.
Okay, and then how does the technology, I'm guessing that's Ecopilot, pull the energy from the thermal storage?
Yeah, so I guess, I hope this wasn't misleading, but essentially what I was referring to is the building itself is able to retain a certain amount of energy just in the building materials. So when I say thermal storage, I mean what is the building made of? There's a little bit, like even your computer desk is going to retain just a little bit of heat, and then you times that by a crazy amount. And then, but again, mostly those heavy building materials, that's the thermal storage we're talking about. So like I said, most buildings have a comfort range, 21 to 24. We can play with that a little bit, right? Or if we know it's going to be a little bit colder tomorrow, and what we don't want is a boiler or a chiller running full throttle to try to catch up. We're trying to plan ahead so you don't have, just like a car, right? You want it to run in cruise control. You're going to save some energy, right? Instead of braking and accelerating. So what we're trying to do is we play with a little bit with that comfort range, and we like to think of it as using the building as a bit of a battery in that way. So there's no big thermal storage tanks or anything like that. So when we do an install, there's our little black box, some temperature sensors, and an energy meter. There's nothing on top of that. That's all for physical devices. After that, we're just implementing more intelligent control.
Okay, well, that wraps up the questions. So thank you everyone for attending. Please reach out to Nick or myself if you have any questions. Please reach out to me if you'd like me to share the recording. Thanks again, and we will talk to you all soon.
Take care. Thanks.
Thanks, Nick.